You've built something incredible. Your Vercel AI SDK application is lightning fast, streams beautifully, and your users love it. But once you hit deploy, you're flying blind. You don't know what's happening, whether costs are spiraling, quality is degrading, or which prompt version is even running. Without observability, you're guessing, and this changes right now. Langfuse gives you complete visibility into everything your LLM does in real time with full context, and it integrates seamlessly with the Vercel AI SDK through OpenTelemetry. Now let's have a look at what you're building towards. Let's play with a simple chat example project in which users can chat with an AI similar to how you normally see it. Here you can see a dummy UI. The user engages with your app, it takes the input in, processes it, and provides a coherent output. We also provided with a web search tool to research questions that the user asks. Now flip to Langfuse. You can see every minor step in the execution chain, the exact timestamp it arrived at, which prompt was used, the token counts, the cost, the latency breakdown, which user, which session, which model, all of it. If something breaks, you know exactly which prompt version caused it. If costs spike, you see it immediately. If quality degrades, you catch it before your users notice. That's complete observability. Here's how it all works. Your Next.js app wants Vercel AI SDK, which uses OpenTelemetry to automatically create traces. The Langfuse band processor intercepts those bands and sends them to Langfuse for collection and visualization. The Vercel AI SDK has OpenTelemetry built in, so you just tell it to send data to Langfuse. That's it. The quickest way to implement it, just point your coding agent like Claude Code at Langfuse's setup docs and let it wire everything up for you. But let's walk through it manually so you understand each piece. First, install the packages via npm. We're installing the AI SDK, the OpenAI provider, the Langfuse tracing client, the OpenTelemetry integration for Langfuse, and the OpenTelemetry node tracing SDK. Next, add your environment variables. You need the Langfuse secret and public key, base URL, and of course an LLM provider of your choosing, in this case an OpenAI API key. Get your Langfuse keys by going to the side panel, clicking on Settings, then API keys and extracting them. Then add them to your environment variable file. Now create a file called instrumentation.ts in your project root. This runs when your app starts and sets up tracing automatically. We import the Langfuse band processor and node tracer provider. We create a Langfuse band processor instance and export it so we can reference it later for flushing. Then we pass it into a node tracer provider and call register to make it the active global tracer. Now open your chat API root and set up your handler. Propagate attributes, add session and user context so you can identify and group related interactions. Set active trace IO sets the trace level input and output, which is especially important with streaming since the response isn't complete until on-finish fires. If you want to take this further, you can manage your prompts in Langfuse instead of hard coding them. Get a prompt from Langfuse using Langfuse client, compile it with your variables, and link it to your trace by passing it into the metadata field. This connects your generation directly to the prompt version stored in Langfuse, so you can see exactly which version produced each output. Now you can A and B test prompts, version them, and see which performs best without ever modifying your code. Now open your Langfuse dashboard and you can see your first trace with complete visibility. Send more messages and each one creates a new trace. You're building a complete dataset of your application's behavior. Now you can actually do things. If a user reports a bad response, search by the user ID, find the trace, see exactly what happened, and reproduce the issue. If you want to optimize costs, filter by model to see which is most cost effective, group by prompt version to find expensive ones, and compare latency across user segments. If you change your prompt, Langfuse automatically links every trace to the version used, so you can compare metrics before and after and run A and B tests. If traces aren't appearing, enable debug mode with export langfuse_log_level equals debug. If auto spans appear in logs, but not in Langfuse, verify force flush is being called. If no auto spans appear at all, Make sure your instrumentation.ts is being loaded before your app code. Now go build something incredible and actually know what's happening.